Welcome back, my dear friends and students. It's a very good morning, good afternoon, good evening, wherever you are in this part of this globe. And as you know, this is the DADM, which is Data Analysis and Decision Making free course under the NPTEL MOOC series. And as you can see from the slide, is the second week and the seventh lecture going on, which is the second lecture in the second week and seventh lecture in totality. And this course total duration, as you know, is for 30 hours, which gets converted into 60 lectures, 30 contact hours, and spread over 12 weeks. And after each week, which consists of 5 lectures, we will have one assignment, and we have already completed one assignment, and we are going to do the second one once 10 lectures are over. That means 6th, 7th, 8th, 9th, 10th are over. Course, you will basically have the question paper examination for this DADM 3, and my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, we will be discussing the 4 utility functions, and I did mention that the utility, or not, I will not use the word utility, the real requirement of A prime, R prime is that basically you want to understand the property of the utility function, and based on that property of the utility function, you want to basically have a understanding how the utility function is, what is the shape, size and the scale parameters of the utility function. So, this word of shape, size and scale parameter, I am talking from the point of view of statistics. So, we use alpha, beta, gamma. So, here they would be A, B, C accordingly. Now, we are discussing the exponential utility function, and if you remember, in the exponential utility function, we found out that the value of A prime was 0, and we will prove it using the simple example, hypothetical example. Again, we have the values of W as given in the first column. The second column is basically the utility function, which is ln of W. And one thing needs to be done, it is the exponential, not ln of W, is minus e to the power AW. So, we have the values of UW. Now, remember, we follow the same step. So, for finding out A and R, we need the values of U prime and U double prime. So, U prime and U double prime would be found out using the concept of del U by del W, which is the change of utility function divided by the change of the wealth function and the value terms. So, this is the first difference, ratio of the first difference, then you will have the ratio of the second difference, because U double prime is d2U by dW2. So, you will find out the difference accordingly, and that would be basically give us the values of A and R. So, if I plot it, if I show it, so this is A, this is the value of R. Now, remember here, see, very interesting, the A values comes out to be constant. So, obviously, it will immediately point to the fact that when I want to find out the first derivative of A, which is A prime, which is the absolute disk coercion property, it will come out to be 0, which matches with the theoretical point which you have just discussed. So, A prime is 0. And similarly, if you remember, the value of R prime was coming out to be the value of small a. That means, if you remember, the formula was minus e to the power A W. So, that value is 0.25. So, R prime comes out to be 0.25 or a value, small a value. Now, from this you can immediately deduce that the absolute risk aversion property is constant and the relative risk aversion property is increasing. So, based on that you can immediately comment what type of utility function it is there, which is basically the exponential utility function. Now, the property, if you remember, when we discussed the quadratic utility function, I did mention that we are going to use the concept that utility function being quadratic and the investment being a normal distribution, there is a one-to-one relationship based on which we will try to proceed and give us some feel that when we do the optimization from the finance perspective. So, now if you plot the utility function which is exponential, the pink one shows, again I am not going to draw it, but I only highlight it. The pink line shows the utility function, which is the UW. The yellow and the turquoise green or the bluish green one would give you the respective values of A and A prime. So, they are almost equal near the 0 line. So, the yellow and the green, if you are able to see, you can plot it using very simple Excel sheet. You just only generate the W values and consider the utility functions. We have already considered the quadratic, we have already considered the logarithmic, we already considered the exponential, and you will later on will see the power for utility function. Just spend 10 minutes, draw it in Excel sheet and you understand. So, once these values of A prime and R prime are plotted, the information which you proved it theoretically, then you basically plotted it on an Excel sheet, you got it, you will basically trying to double verify, triple verify, plotting it as a graph. So, that will give you what type of property the utility function has. Now, we will go into the utility function which is power. This is the fourth one. Obviously, there are other utility functions also, this Kara, Hara and all these things, hyperbolic absolute risk aversion property. So, we are not going to go into that until unless required for the genuine problem solving. I am just mentioning it. So, now if I want to find out the value of u and u prime. So, again u value is given as c w to the power c and c value would be greater than 1, and if you are differentiate it will be found out accordingly. So, consider c is greater than 1. So, it will be c square, this is the first value, so you can basically find out A minus c square c minus 1 w c minus 2 c square w c minus 1. So, utilize this equation and you can find out the value of A prime. Similarly, you want to find out R formula is basically minus of W. W, remember I am repeating it time and again, but please bear with me, W is positive. So, it is minus W u double prime by u prime, find out the value, differentiate that, find out R prime, and this comes out to be 0. Now, here W square or W is as such positive, W square is positive. So, the denominator which is in the formula of A prime is positive, C is positive, so C and greater than 1. So, it is C minus 1 is greater than 0. So, the whole value of A prime is positive, and if it is C is less than 1, obviously it will be negative. So, we will take it accordingly. So, we use the utility function for people with decreasing absolute risk aversion property, here decreasing because C value is less than 1. So, it will be decreasing absolute risk aversion property, but here the R prime value would remain as 0 as it is. So, it will be a constant relative risk aversion property as shown here, and it can be easily proved, just spend 2 minutes and you can deduce. So, these are the mathematical one, then we will go into the using the Excel sheet. Now, again I plot the values of W and I have on the second column the u w values, which is basically c in w to the power c. These are the values are taken, you take any value of c and consider c is less than 1. Now, again we follow the same step, and please bear with me, I am repeating it time and again. So, you will first find out u prime would basically be delta u by delta w, that means the differences of u into in two cells, one is 0.33 divided minus 0.3 divided by 3 minus 2. So, here in the numerator you have delta u and in the denominator you have delta w. So, those values will give you u prime, which I have not drawn here. Then I will basically find out u double prime. Again u double prime we know it is d2u by dw2. So, find out the second difference for the value of u, find out the second difference for the value of w, find out the ratio, and that will give you u double prime. Utilize these values with the formula that A is equal to minus u double prime by u prime, and find it, and once these values are found out, so you will basically have AW. Now, if I want to go to RW, so RW value formula is again the same, just you multiply by W. So, in minus W u double prime by u prime, you put it, you find out this value. So, very interesting, note down. So, the R values are all constant. So, if it is constant, what it would mean, I will come within few seconds. Given A, so again you will find out A prime would be d of A by d of W, which is delta of A. Delta means the difference of A two consecutive values divided by the difference of W. So, that will give you A prime, which is given in the fourth column. I will not highlight it, I will just take my cursor accordingly. Now, if you see the second last column, which is RW, so that gives us the value as constant. So, if I differentiate that, that will give me the values of R prime, which is 0. So, once you have 0, you immediately know that the relative risk aversion property is constant, and corresponding to the value of C, you know what is the absolute risk aversion property. So, we have been able to define, okay, let me come to the graph, then I will basically summarize, sorry for that. So, again I basically plot the values of power utility function, I follow the same in the index the same coloring scheme. The pink one I am not going to highlight it, the pink one is basically for the utility function, the yellow and the greenish bluish green are basically for A and A prime, and the darkish one, those very dark violet and the brown one is basically for R and R prime. So, you can plot it. Now, what we have done is that we have basically given the properties of A prime and R prime, derived it theoretically for 4 utility functions, and then double verified that using a hypothetical set of values for W and UW, and then shown it that the calculations which you are doing it theoretically using simple calculus matches with the fact that what you can prove it pictorially, and that basically classifies the 4 utility function into the category. Categories means that I am able to understand what type of utility function I use, provided I know A prime its properties, R and R prime in its properties, and I also know something about the parameter values which I am utilizing. So, consider an example. Suppose u, which is the utility function, is w to the power 1/4 some power, and we are required to find out the properties of the utility function and also draw the graph. So, of the utility function, so u prime would be, you differentiate that, it becomes 1/4 or w to the power minus 3/4. So, obviously, as w is positive, so this whole equation, because 1/4 is obviously positive, so this whole value is basically greater than 0. So, obviously, the first derivative is greater than 0, which basically satisfies the first property, which is property of non-satiation. Now, when I go into the second property, again I differentiate the second time, the value comes out to be minus 316 by w to the power minus 7/4. W value is always positive, so that value w to the power minus 7/4 is positive, 3 by 16 is positive, but there is a minus sign which immediately points to the fact that u double prime is less than 0. That means, you have a risk aversion property in that human being or the decision maker. Hence, the utility function has shown the two fundamental property of non-satiation and risk aversion, and based on that we can say that the person has the non-satiation property holds true and the risk aversion property also holds true. The risk aversion property is one of the three, which is I love risk, I am indifferent to risk, and I am basically averse to risk. So, now let us find out the absolute risk aversion and relative risk aversion property. Just put them in the formula, find out A, which is minus u double prime by u prime, and that comes out to be 3/4 by to the w to the power minus 1. So, this just simple calculation what you do, if you check, you just I am just putting the values of u prime and u double prime. Then again I put the values of R, and now R from formula is only I multiply it by W with respect to A which I have, and I put it, the value comes out to be 3/4. Now remember one thing, the moment R comes out to be constant, you immediately know that R prime is 0, that means you have constant relative risk aversion property, that is finalized. When I go to A, it is given by 3/4 by W to the power minus half, 3/4 is always positive, W is always positive, you differentiate that, but with a minus sign, which will immediately give us the information that A prime, which is absolute risk aversion property, is decreasing. Now from the two equations which I have already summarized, I am just going to read it. We have decreasing absolute risk aversion property, that is the amount of wealth increases, the amount held in risk asset also increases. That means you have decreasing absolute risk aversion property, that means I want to take risk. And on the other hand, you have constant relative risk aversion property, that is the amount of wealth increases, the percentage held in risk asset remains the constant. So percentage wise it remains fixed, but in the absolute sense I am going away from being a risk decreasing risk aversion, that means my property of trying to run away from risk is basically decreasing, that means I want to take risk. So I plot this graph in a simple Excel sheet. I have not done the values of u prime, a prime, r prime. I am just going to draw the, because it becomes too cluttered, you can utilize different Excel sheet to find it out. I plot the values of value of u on the y axis and w along the x axis. If I plot it, the value comes out to be as it is. So it is increasing, but increasing at a decreasing rate. Now we have been doing trying to find out what is utility, the expected utility, and why it is important, then the concept of absolute risk aversion, relative risk aversion, u prime, u double prime, non-satiation, all these things. What actually they are utilized, I will come to that later. And if you remember, I did mention expected value and variance of a utility function, which was basically some sort of positive and negative benefit we want to optimize, and would be coming out later. The actual value of the expected utility is of no use except when comparing with other alternatives. So, you want to rank the alternatives, obviously you need the expected value. Hence, we use an important concept of certainty equivalent, which is amount of certain wealth or risk free wealth that has the utility level exactly equal to the expected utility value. So, based on that, once we are able to find out the expected value and the certainty value are matching, certainty value means it is a non-probabilistic decision, is a deterministic decision, while in the utility case you have a probability, hence you based on that you want to find out the expected value. Thus, the utility level exactly equals to the expected utility value. So, we define the certainty value to be UC, C is the utility function, as E expected value of the utility function. So, what we are doing is like this. So, this is the utility, let me use the different color, sorry. So, consider there are 3 arms. So, probabilities are given P1, P2, P3, and I am saying it is equivalent. So, the probability P is equal to 1 and C value. So, what okay, and also remember I have not marked, these are W1. So, obviously it will have an equivalent of UW1, W2 which will have an equivalent of UW2, W3 which will have an equivalent of UW3. So, if I want to find out the expected value for this, expected value of UW would become, I am writing in the bottom part, so it will be easier for me to compare. So, it becomes P1 into UW1 plus P2 into UW2 plus P3 into UW3 and on the right hand side I have, so here the probability is 1, but I will use the same utility function, do not change the utility function. It is UC into 1. So, this one value is coming for this one, while this value is coming from here, and you know the utilities have been found out accordingly. So, if you balance that, the C value based on which you want to find out will come out immediately. So, based on that immediately take the decisions. Suppose that if we have, so why it is important? Suppose that we have a decision process with a set of outcomes, their probabilities and the corresponding utility values are given. So, as I considered in the last example, in case if you want to compare the decision process, we can find the certainty equivalent, so that comparison is easier. To find the exact form of the utility function for a person who is not clear about the form of utility function, he or she uses this in order to find out how I am going to come that. So, first let us understand the example of what is certainty value considering the utility function is given. So, let me read out the problem. Suppose there are two options, option 1 and option 2. So, under option 1 you toss a coin, a simple unbiased coin, and if a head comes, which probability half, you win 10. But now mark my words, you are winning 10, but it is not giving you, it is not mentioned that what is the net worth which accrues to you if you win 10. While if a tail appears, you win 0, that means you do not. Again 0 value is the so called wealth, it does not give you any net worth, what is the actual value. Under option 2, which is on the other side, you get a amount of m, we do not know the value of m. Now consider for both the cases the utility functions are same and it is a quadratic one given by w minus 0.04 into w square, is a utility function. Now I need to find out the m which will balance the expected value on both for both option 1 and option 2, hence we can say that the value of m which you want to find out is the certainty value. So, what do I do? In the first case, when there is a head and a tail and the actual value of w is 10 and 0, we will put the value of 10 in the quadratic utility function, which is w minus 0.04 into w square multiplied by half. So, that is one part, and then put again the value of 0 into utility function and multiply it by half. If we add both of them, that will give me the expected value of that option where there are two outcomes, the values are 10 which I see, and what is the actual accrued value to me would be given by the utility function once 10 is placed there. And on another case, when the outcome is value 0, what is the total value which accrues to me would be given by the fact when 0 is put into the utility function. Now, what happens to the other option? In the other option, which is deterministic, you put the value of w m in the value of the utility function and multiply it by 1 because it is the certainty value, equate both the sides of the equation by the expected value which you consider to be same and find out the value of m. So, that m value would give you the certainty equivalent such that if that amount of money is kept or the value is kept on one side of the table and on the other side of the table you will basically have that option where there are two outcomes with a head and tail. You as a person who has a utility function which is given by the quadratic one, you will be indifferent. Now, mark my words what I said in the last few seconds, that means if your utility function is same, but if your utility function is different, obviously the m value will change, hence the value which is to be kept on the table will change accordingly, and then the certainty value will change depending on both the utility function, both on the risk aversion property or risk loving property or the risk indifferent property of the human being or the decision maker who is going to take the decision. For the first option, the expected utility value would be 3, you can basically find out putting them in the equation. That means, put 10 into the utility function, multiply half, you put 0 into utility function and multiply half, add both of them and the value is 3. while the second option has a utility which is given by m minus 0.04 in m square. To find out the certainty equivalent, we should have basically um as given here. So, the left hand side and the right hand side should be equal. So, if we equate, you find out that value of W as 3.49, which means that 3 rupees 49 paisa or whatever the units is, if that is placed on the table and you have the other option which is the head or a tail, if this depending on the value of 10 or 0 you are getting. If you want to be indifferent, then the value which will satisfy you to be indifferent is 3.49. If any value is placed more than that and less than that, your decision will change. So, more than that, obviously it will mean that I will go for the certainty value, not I will not use the word certainty value, the amount which is fixed and kept on the table. If a value is kept less than the certainty value, obviously in that case I would rather technically go for the gamble, because on the long run the expected value of the gamble is more. So, the above example illustrates that you would be indifferent between option 1 and option 2, as I said 3.49 on the other side and the gamble on the other side. Now, suppose if you face a different situation where you have an option 1 as before as the gamble, but a different option 2 where you have rupees 5. So, that means 5 is being given and is a certainty value. It is not the certainty value in the case when it is a deterministic case, and then if you want to find out the utility for the deterministic case, it will be when you put 5 in the utility function, which is 5 minus 0.04 into 5 square, it comes out to be 4. Now, that 4 value is greater than 3.49. So, obviously in that case you would choose option 2 depending on the expected value which is higher. So, if you remember, I did mention 3.49, any value more than that you will go for that certainty, not certainty, that deterministic case, and any value less than 3.49 you will go for the probabilistic case. Now, if I go to the venture capital problem where the utility function was half, w to the power half, I should not use the word half, it is basically w to the power half, then in that case you can find out the certainty value, because that will basically make a balance, give you an idea that where you want to basically balance depending on the decision. So, the venture capital problem, the certainty value of the option 2 would be given by 370881 as the utility, considering that you have a utility function which is w to the power half, comes out to be 609. So, only 609 is being balanced by the government case, where the government actual expected value was 609. So, 609 on the left hand side, 609 on the right hand side would give you a value of C, which should be kept on the table. 609 you are comprehending, which is the actual value which will be coming out. Based on that, you find out is 370881. Now, if I want to find out and give us some concept of that why that utility function certainty value is important, or risk aversion property will select an equivalent certainty event rather than the gamble, because he wants to make it sure that he does not lose anything. A risk neutral person would be indifferent between the certainty value and the gamble, while a risk seeking person would select the gamble rather than certainty value, because one of the arm would give you a higher return. So, hence the risk loving person thinks in the long run there is a chance that, which is true, that it may come out that he or she will win that and basically take a decision which basically satisfies his or her risk criteria. With this end, I will end the 7th lecture and continue more discussion about the utility function and basically then go into the problem of the optimization. Have a nice day and thank you very much.